Airflow in the human respiratory system is tidal, meaning that air enters the lungs by the same route that it leaves. The route inward begins at the nasal passages or mouth, passes through the pharynx, larynx, and trachea, and then through increasingly branched respiratory tubes, the bronchi and the bronchioles, before it finally reaches the millions of tiny air sacs, called alveoli, that make up the bulk of the lungs. The ability to inhale and exhale is based on the anatomy of the lungs and its surrounding structures. Each lung is surrounded by two pleural membranes. One membrane is firmly attached to a lung, while the other is attached to the wall of the thoracic cavity. Fluid fills the pleural cavity between the membranes. During an inhalation, the diaphragm and other chest muscles contract, causing the thoracic cavity to expand. The thoracic wall and its attached pleural membrane move outward, causing suction in the pleural cavity. The suction pulls the second pleural membrane along, as well as the lung to which it is attached. As the lungs expand, their interior gases also expand. The expanded air has a lower pressure compared to the air outside the body. Air rushes into the lungs to equalize the pressure. This is inhalation. When the diaphragm relaxes, the elasticity of the lungs causes them to recoil and push air back out through the airways. This is exhalation. Although breathing is an active process of muscle contraction followed by relaxation, air movement is passive. Air passively flows from regions of higher pressure to regions of lower pressure. During an inhalation, the pressure in the alveoli drops lower than the atmospheric pressure, and air rushes into the lungs. During an exhalation, alveolar pressure increases relative to atmospheric pressure, and air rushes out. This movement of air brings the alveolar pressure back to atmospheric pressure. The pressure in the pleural cavity is always negative with respect to atmospheric pressure. During an inhalation, as the chest expands, the pleural cavity pressure becomes even more negative, providing the suction to expand the lungs. During an exhalation, the pressure in the pleural cavity returns to its original value.